Hello again. We're looking at example 4 of your pre-calculus textbook. This is lesson 1-3 about functions and graphs. On example 4, this one specifically is called a piecewise function here. And what piecewise function is, it's literally pieces. Like this is two different equations going on. I use the top one when x is less than 1 or equal to, and I'm going to use the bottom equation for when x is greater than 1. So you can see that they've taken just a few numbers that are 1 or less, which is this first category here, 1 or less, and they plug those in. For all of these numbers, we're going to use this equation x plus 2, which is why they have it right here. So if I plug that in, if I plug 1 in, I'm going to get 3. Which means my answer is 1, 3. If I plug 0 in, I'm going to get 2, which gives me 0, 2. If I plug negative 1 in for x, I'm going to get positive 1, so I write it as negative 1, 1. Negative 2, if I plug that in, I'm going to get 0, so therefore it's going to be negative 2, 0, and you can kind of see the pattern. When you begin to graph these, what they're going to do is end up giving you this line right here. Okay? Now, because there is an equal sign, notice that this is a solid dot right here. Now, for everything greater than 1, which is this one, we're going to say that it's 4. That means no matter what number the x is, the y value, because that's what f of x means, f of x is going to be 4. So notice that if I pick 1.5, it's 4. If I pick 2, it's 4. If I pick 3, it's 4. If I pick 4, it's 4. If I pick 5, if I were to pick 1,000, it would still be 4. And so, since all of your y values are 4, that's going to give you that flat graph here. Notice there's an open circle there because there is no equal with this particular one. It's everything above 1. So from here on, the graph is going to stay flat at positive 4. When I put both of these together, this is referred to as a piecewise function. We're literally just putting two functions together, and therefore it's pieces, so therefore it's a piecewise function. It says we can use the graph of the piecewise function to find the range of f. The range of the piece of on the left is, and here's just wording, it's y such that y is less than 3. The range of the horizontal piece on the right is y such that all the y values were equal to 4 because it was a constant one. The reason this is 3 is because every answer over here was less than 3. And so that's what they're stating right there. Okay. So you could write it this way, which is called set notation, or you can write it this way, which is function notation. So from negative infinity all the way to 3, along with, that's your range, from negative infinity all the way up to 3, because it never goes lower. Negative infinity is way down here, and then it keeps rising. And the highest point there is 3. So it's that, and then in union with 4. The range is also in conjunction with 4, since 4 stays flat. Okay, let me move over to this next page. If we were going to graph this particular piecewise function, again, you would have your graph here, or a chart. Let me do an XY chart. I'm going to, when everything is less than or equal to negative 1, it's just a flat out 3. So that means if I pick negative 1, negative 2, negative 3, negative 4, and so on, the answer just for y is going to be 3 every time. As opposed to this one, if I make an XY chart, and I plug in, this is everything greater than negative 1. which would be 0, 1, 2, 3, and so on. Now, this one is going to get included. The negative one is going to get included. Here, you can start, you can't really start at 1 because it's not going to be included. And you're going to use this equation right here, which is x minus 2. So 0 minus 2 is negative 2. 1 minus 2 would be negative 1. 2 minus 2 would be 0. 3 minus 1 would be, and 3 minus 2 would be 1. If I graph those on a graph, and of course, if you had real graph paper, this would maybe be quite a bit easier for you. But if I graph these first, it's going to be at negative 1, it's going to be 3, and it's going to be solid at negative 2, at negative 3, at negative 4, and so on. So that means this graph is going to have a solid dot here, and it's going to continue on level in that direction. And then I'll change colors here. If I'm going to do this one, then it's going to be 0, negative 2, 1, negative 1. At 2, it's going to be 0. At 3, it's going to be 1. So you can see the graph is kind of going up that way this time. Now, I would put an open circle there at negative 1 because I can't include negative 1, just everything right up to that. And so this is what my piecewise function would look like on that. Now, as you can see here on the board, there are other piecewise function. One specific one is called step function, which is really called the greatest integer function. If you want to read about that down through there, you'll see that step functions get their name because they look like steps. But anyway, that'll be for another day. Hope this was helpful.